flash floods,
flooding,
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 floods, flash floods,
flooding,
deadly flooding.
What if I told you that everything we know about floods is wrong? The way we predict them is outdated, the maps we trust to keep us safe are failing, and places that we once considered low risk are now at risk of being flooded. Look, floods aren't just getting worse, they're getting unpredictable. In the last few years, we've seen cities drowned in record-breaking rain, neighborhoods wiped off the map, billion-dollar disasters happening over and over again. But here's the part no one's talking about. This isn't just bad luck. Something is changing and happening faster than we expected. So today we're breaking it all down. What actually causes floods? Why are they becoming more frequent? And what can we do before the next one hits? So let's start with the basics. How does a flood really happen? Floods might seem simple. Too much water, not enough places for it to go. But the truth is not all floods are the same, and understanding the different types is key to figuring out why they're happening more often. First, there's the flash flood. This is the one that catches people off guard. 1 minute it's just heavy rain, the next water is tearing through the streets, sweeping away cars and turning basements into death traps. Flash floods can happen fast, sometimes in minutes, especially in cities where rain has nowhere to go. Then there's river flooding. This is the slow burn. Days or weeks of relentless rain cause rivers to swell beyond their banks, creeping into homes and farmland. These are the floods that stretch for miles, turning entire regions into lakes. Coastal floods, they come from the ocean. When hurricanes push massive storm surge inland, the sea doesn't just rise, it invades. Streets disappear, buildings crumble, and salt water poisons everything it touches. And finally, there's urban flooding. This one doesn't need a storm or a swollen river. It happens when a drainage system fails, when a city's design traps water instead of channeling it away. You don't need a hurricane for this, just the right amount of rain at the wrong time. I live in New York, so I experienced some of these events myself. Hurricane Sandy and several flash flooding events, such as this one in 2021, made me really start to explore floods in more detail. Different causes, different timelines, but they all share one thing in common. They're happening more often. Floods have always been a part of life on Earth. Rivers rise, storms come and go, and coastlines shift. But something is different now. The frequency, the intensity, and the unpredictability, it's all accelerating. So what changed? First, the climate. A warmer planet means a wetter planet. As temperatures rise, the atmosphere holds more moisture. That moisture has to go somewhere, and when it finally falls, it doesn't come as a light drizzle, it comes as a torrential rain. Storms that once happened once in a century are now happening every decade, sometimes every few years. The second is that we built ourselves into a corner. Cities are expanding faster than they can handle, replacing forests and wetlands with concrete and asphalt. Nature used to absorb excess water, slowing it down. Now the water has nowhere to go. It rushes over streets and sidewalks, overwhelming drainage systems designed for a climate that no longer exists. Then there's deforestation. When we strip away the trees, we remove nature's flood defense. Their roots once soaked up rainwater, stabilized the soil, and kept rivers in check. Without them, floods hit harder and landslides become more common. And last, our infrastructure is starting to fail us. The dams and levees, the drainage systems that we built decades ago weren't designed to handle this level of flooding. They're outdated, overwhelmed, and in some cases breaking down completely. This is why floods aren't just a coastal problem or a seasonal event anymore. They're hitting places that never had to worry before. And to prove it, let's look at some real-world examples. 3 devastating floods, 3 very different places, all pointing to the same dangerous trend. Valencia, Spain isn't the first place you think of when it comes to extreme flooding, but in recent years, the city has been hit by devastating rainfall events that have turned its street into rivers. Mediterranean climates are supposed to be dry for much of the year, but climate change is shifting weather patterns. More moisture in the atmosphere means heavier, more intense downpours. In Valencia, that meant more rain in a single night than the city usually gets in months. Too much, too fast, and nowhere for the water to go. Now let's move across the Atlantic. North Carolina in the United States knows hurricanes, but even here, floods are breaking new records. Hurricane Florence in 2018 dumped over 30 inches of rain, turning highways into waterways and cutting off entire pounds. The scariest part, this wasn't just the storm surge. It was days of relentless rain that followed, pushing rivers and reservoirs past their breaking points. Hurricane Helene in 2024 brought catastrophic flooding to North Carolina, unleashing torrential rain and storm surges that overwhelmed coastal defenses and pushed inland rivers to record heights. Unlike past storms, Helene's slow-moving nature caused it to dump relentless rainfall over several days, causing flash floods in urban areas and prolonged river flooding that cut off entire communities. This isn't a one-time event. Warmer ocean temperatures are fueling stronger hurricanes, bringing more water and slower-moving storms. More storms, more flooding, and more damage. Finally, let's talk about a place most people wouldn't expect, America's upper Midwest. This region isn't dealing with hurricanes, and yet in 2024, massive floods drowned farmland and a small town's under feet of water. The culprit, a deadly combination of rapid snowmelt and relentless spring rains. Winters here are getting warmer. More snow is melting faster than before over overwhelming rivers at the exact same time that heavy spring rains are hitting. Flooding on a scale that the region simply wasn't prepared for is the result. And yet when you look at flood maps, insurance policies, and disaster planning, none of it is caught up. And that brings us to the next problem. Why are we still using outdated flood zones to predict risk? Let's talk about eastern Kentucky. In the summer of 2022, a devastating flood tore through the region, destroying homes and taking lives. According to FEMA's official flood maps, only 12% of properties in the hardest hit counties were designated high-risk zones. But when independent researchers reassessed the data, they found the real number was closer to 51%. That means thousands of people had no idea they were at risk, and worse, they didn't have flood insurance. And this isn't just a problem in Kentucky. In Dallas-Fort Worth in August 2022, 15 inches of rain in just 18 hours, damages and economic losses estimated at $6 billion. Illinois in the same month, 10 to 13 inches of rain flooded the entire communities. Death Valley in California, a year's worth of rain in just 3 hours, shutting down every road in the park. In St. Louis, Missouri, a record-breaking 9 inches of rain in a single day. Someone called it America's Summer of Floods, but the truth is this isn't a one-off event, and flood maps aren't keeping up. These maps that decide who is at risk for floods, who needs insurance, and where cities are built, and what areas should prepare are based on the past and not the future. Many of these maps haven't been updated in decades. In Kentucky, some hadn't been revisited in 14 years. In North Carolina, a study found that 85% of flood damage reported to NOAA between 2006 and 2020 happened outside FEMA's designated flood zones. And there's an even bigger flaw. FEMA's maps focus almost exclusively on coastal and river flooding. They don't account for flash floods caused by extreme rainfall, the kind that overwhelm small towns in Kentucky, or the kind that submerge entire highways in Texas. FEMA itself estimates that by the end of the century, high-risk flood areas will increase by 55% along the coasts and 45% along major rivers. Yet their official maps don't account for these future risks. Governments, insurers, and risk analysts are already turning to more accurate, high-resolution flood modeling. One of these models is JBA, a global flood risk analysis company that maps flood threats at a 5-meter resolution, far more detailed than FEMA's broad-stroke approach. And unlike FEMA, JBA's models don't just focus on major rivers or coastlines. And look, these models were tested against real-world disasters, including Hurricane Harvey in 2017 and the European floods of 2021, and in both cases, it identified far more flood-exposed sites than other models. More accurate flood models mean communities can plan ahead. Businesses in high-risk zones can reinforce buildings, homeowners can get insurance before disaster strikes. Because right now, millions of people don't even know they're at risk until the water is right at their door. But how do we actually analyze these floods in real time? How can we track water movement, predict where it will go, and improve response times? That's where satellite imagery and advanced geospatial technology come in. Satellites are already monitoring flooding across the globe. NASA and the European Space Agency use high-resolution imagery to track storm surges, river overflows, and soil moisture. These images give emergency responders a clear picture of flood damage, helping them plan evacuations faster. But what happens when the storms or the clouds block the view? That's where synthetic aperture radar, or SAR, comes in. Unlike traditional satellites, SAR can see through the clouds even at night, making it one of the most powerful tools for flood mapping. During Hurricane Harvey, SAR provided real-time flood data while the storm was still raging, giving emergency teams information that aerial surveys simply couldn't match. On the ground, flood sensors are predicting even more data. River gauges and smart flood monitors track water levels in real time, feeding that information into AI-powered models that can predict where the water will go next. Some cities are already using this technology to send instant alerts when floodwaters start rising, giving residents critical minutes to evacuate. And companies such as Fathom, First Street, and 7 Analytics are all starting to use these new data sources to create advanced models and maps that we can use right now to get a better picture of flooding. So if we have all this technology, why aren't we using it everywhere? The biggest reason is simple: change is slow. FEMA has yet to fully integrate satellite and AI-driven flood models into its official risk assessments. Many cities and insurance companies still rely on FEMA's outdated maps, even when private models show an entirely different reality. And funding remains a constant barrier. While investing in real-time flood monitoring could save billions in damages, many communities lack the resources to make it happen. But let's take this a step further. How do we put these tools to the test? Let's see what happens when we analyze a real-world flood event. In 2024, Northfield, Minnesota found itself underwater. Heavy rainfall combined with rapid snowmelt sent the Cannon River surging 6.5 feet above normal levels, spilling into streets, businesses, and homes. This wasn't just an unlucky weather event, it was a perfect storm of conditions. Northfield sits in the driftless region, a unique landscape in the upper Midwest that was never flattened by the glaciers. The result, rolling hills and deep river valleys that create pockets where water can collect rapidly. Unlike flatter regions where floodwaters spread out evenly, the flooding here is more localized, hitting low-lying areas the hardest. And this wasn't just one town. Across the Midwest, communities faced different challenges. In places like Iowa, where the land is flatter, the water spread out like a table overflowing, covering miles of farmland and urban areas. In hilly terrain like Northfield, the impact was more concentrated but just as devastating. Now imagine if we could monitor this in real time, predicting flood zones as they form and updating emergency response plans before disaster strikes. Here's the thing, it's not just a theory, we can actually do it. We start with real-time river data. The US Water Model provides updated river heights every 15 minutes, tracking the Cannon River and other waterways as they rise. This alone gives us an early warning, but it doesn't tell the full story. To get a true flood risk picture, we need to combine that with height above nearest drainage or the hand data set. This dataset allows us to determine which areas are naturally lower in elevation compared to the surrounding landscape, essentially which areas will flood first as the water rises. This provides great insights, especially into things like flash flooding in concentrated urban areas. But there's another layer. By comparing hand data with actual elevation models, we can pinpoint not just where the water is likely to flow, but which buildings and infrastructure are most at risk given the elevation relative to where the water is sitting. What's particularly interesting about this is that the data is not static. As river heights update, so does the flood risk model, meaning we're not looking at flood predictions from a decades-old map, we're seeing the flood unfold as it happens. Look, I know Northfield is just one example, but to scale this out, we can use distributed computing with tools like Whereabouts. This model can scale to monitor flood conditions across the entire nation, every river, every town, updated as often as we need. Instead of waiting for reports after the fact, emergency responders could see which areas are flooding in real time, where floodwaters will go next, and which buildings are in immediate danger. This isn't the future of flood monitoring, it's something we can do right now. The technology exists and the data is available. So with that said, if we can monitor the damage and see where floods are going, how do we build for the future? What can we do to protect our cities, homes, and infrastructure from the next big flood? We know floods are getting worse, but how can we adapt? The first step is rethinking how we build. Urban areas covered in concrete force water to collect and overwhelm drainage systems. The solution, smarter urban planning. Green infrastructure like permeable pavement, rain gardens, and flood parks give water somewhere to go instead of turning streets into rivers. Dams, levees, and storm drains built years ago weren't designed for today's climate. Many are already falling under the pressure of more intense storms. Strengthening flood defenses means upgrading drainage systems, reinforcing levees, and building stormwater reservoirs to absorb excess water before it becomes a disaster. And we need better emergency planning. Governments must adapt to real-time flood prediction tools, not just outdated maps. Insurance companies need to stop relying on FEMA's flood risk zones and instead use AI-driven flood models to account for climate change. Homeowners need to understand their actual flood risk and take calculations before the next flood comes. But what about individuals? What can you do? First, know your risk. If you live in a flood-prone area, don't assume FEMA's maps have you covered. Use tools like First Street's flood factor or private flood models that take climate change into account. Second, prepare your home. If you live near flood zones, install barriers, elevated appliances, and ensure you have the right insurance. Take proactive steps to prepare yourself before the next flood comes. And third, push for change. Governments update policies when people demand it. If your city isn't updating flood response plans or investing in better infrastructure, let them know. The data is there, the solutions exist, but action only happens when the pressure is high enough. We can't stop rain, we can't stop the storms, but we can stop being caught off guard. So the real question is, are we going to wait for the next disaster, or are we finally going to get ahead of the flood?